In this video, we're going to talk about another type of discrete probability distribution. Specifically, we are going to look at a Poisson probability distribution. So when we think about a Poisson probability distribution, this is a distribution that applies to occurrences over a specific interval. So when we're thinking about occurrences over some kind of specified interval, that is a Poisson distribution. The random variable x in this distribution, this is the number of occurrences. Right? So our random variable is the number of occurrences over that interval. When we think about what that interval might be, that interval could be time, it could be distance. We could have some interval where we're saying how many times does something occur over some particular area. It could be over a volume, so what's the number of occurrences over some volume. And then our probability formula, it is given by this. Right, so it uses the mean, right? So the mean number of occurrences over the interval raised to the number of occurrences we're trying to find the probability of, times e to the negative of that mean, all divided by x factorial, the number of occurrences factorial. For Poisson distribution, the random variable x, as we just mentioned, is the number of occurrences of an event over an interval. So how many times does something happen over some interval? The occurrences, they must be random. The occurrences must be independent. Right, so if you have one occurrence, it should not affect whether or not there's another occurrence. And then finally, the occurrences must be uniformly distributed over the interval. Right? And uniformly distributed, we'll actually talk about what that is more in chapter 6, so in some future videos. But here, if we think about this as over, if our interval is time, uniformly distributed just says it's just as likely for it to happen at any moment in that interval. And so in the first millisecond, or the first hour, or the 7th millisecond, or the 7th hour, over over any of that interval, the occurrences are equally likely. For the parameters that are associated with a Poisson distribution, the mean is mu. The standard deviation is going to be the square root of the mean. So that means that the variance, sigma squared, is exactly the same as the mean. So when we have a Poisson distribution, this is true. So let's look at some differences between the binomial and Poisson distributions. The binomial distribution is determined by the number of trials and the probability of success. P. But the Poisson distribution, it is only determined by its mean. In a binomial distribution, the possible values for the random variable x are 0. So we could have no successes, 1, 2, anywhere up through n successes, where n is the number of trials. For a Poisson distribution, the possible values are going to, we could have no occurrences over the interval. 1, 2, 3. But this goes on forever. There is no capacity here. We could have 1,000,000 occurrences over an interval. It might be really, really unlikely, depending on how we've determined this interval and what the setting is. But we could have really any number of possible values that could occur. All right, so let's look at how we can calculate some of these using StatDisk. So again, StatDisk is a software that's associated with the Triola series. You can find it online. It's an online program that you can use. So we're going to use that. Here we have our example. Over a 20-year period and 280 core years, there were 196 deaths by horse kicks in the Prussian army. We are going to find the mean number of deaths by horse kick per core year, and then we're going to find the probability of 0, 1, 2, 3, and 4 deaths in a single core year. So to find the number of deaths by horse kick per core year, we have 196 deaths divided by the number of core years, which is 280. So when we take 196 divided by 280, we get 0.7 deaths per core year. So that is the information we really needed in order to be able to go through and find the probability of 0, 1, 2, 3, and 4. So we're going to go to StatDisk. So I'm going to go here. So I go to statdisk.org. Here on statdisk.org, I'm going to choose Analysis, Probability Distributions. Here we are now dealing with a Poisson distribution, so I choose that. All I need to know is the mean, and our mean is 0.7 here. That is, so each core year, the mean number of deaths by horse kick is 0.7. So we evaluate this, and this gives us all kinds of information. Really, in theory, these values of x would go on forever and ever. They stop after they see zeros for a long period of time in terms of the probability. So we are interested in 0. So associated with 0, here, we have a probability of 0.497 if I go to the third decimal. 0.497. For 1, it's that second value, 0.348. So right there, 0.348 is the probability of exactly 1 death, 0.348. Probability of exactly 2 deaths is the next value down, 0.122, and then 0.028. And then our final value, probability of exactly 4 deaths by a horse kick, is right here, 0.005, if we go to the third decimal place. here are some actual results. So actual results, we had 0 deaths in 144 of those 280 core years. So if I take 144 out of 280, the percent of core years that had 0 deaths was 0.514. That's kind of close to this value, right? So it's different by right around 2%. 91 out of 280. We get 0.325. So again, that's reasonably close to this value, off by just over 2%. In the next one, we have 32 core years, 32 out of the 280. That's 0.114. That value is reasonably close to our 0.122. Next, we have 11 out of the 280 core years. That's 0.039, which is pretty close to that. And finally, 2 out of 280. Is 0.007, and 0.007, that value is really close to 0.005. So does Poisson distribution seem to be a good fit? Yes. That we didn't use a statistical test or anything to determine that. We'll talk about that kind of test way later on in like chapter 10. But that is one way that you can go through and you can do these comparisons. Just kind of see if it passes an eye test. That's the Poisson distribution. Be careful of mixing up Poisson distributions and binomial. They're not alike, but students and people often interchange those two. So Poisson distribution, number of occurrences over an interval. Binomial is a fixed number of trials, 2 outcomes for each trial. Probability of success stays the same from trial to trial. All right, we'll talk to you next time.